Okay, so today we're going to be working on number 9 of Mastering Physics. Dan is gliding on his skateboard at 2 meters per second. He suddenly jumps backwards off the skateboard, kicking the skateboard forwards at 6 meters per second. Dan's mass is 50 kilograms and the skateboard's mass is 7 kilograms. So the question is asking how fast is Dan going as his feet hits the ground. So this is talking about an I guess you could think of it as an explosion, so kind of the opposite of a collision. So it's when two objects kind of separate into two different parts. The most important thing is to realize that momentum is going to be conserved in this problem. So first we can just draw it out just to make it visually understandable. So here's the 7 kilogram skateboard, and Dan is just a box at 50 kilograms, and together they're traveling at 2 meters per second. After this type of explosion, these two masses will separate, and as a result, the skateboard is going to be moving at 6 meters per second, but the problem is asking us how fast Dan is going. So we know the velocity and the mass of the skateboard after this explosion, but we are trying to find the missing piece, which is Dan's velocity. So here we have kind of just like a basic representation of the conservation of momentum. So momentum before the explosion would be equal to the momentum afterwards. But if we kind of just substitute the masses and the velocities involved, here we'll see that the masses together with their initial velocity will be equal to, will make Dan M1 and V1 and the skateboard M2 and V2. But this total momentum should equal the total initial momentum. So if we just substitute these values, we'll see that M1 is Dan, so that would be 50 kilograms plus the skateboard. They are moving together at 2 meters per second, seen up here. And then that would be equal to the final momentum, which is Dan's mass times his unknown velocity plus the skateboard's mass times the resulting velocity of 6 meters per second. So if we do some algebra, we'll see that the final velocity that Dan has is 1.44 meters per second. And something to point out is that we don't want to make this value negative. That's what I did initially, and I got the problem wrong just because I assumed that when Dan kind of kicks back the skateboard, he's going to be traveling at a negative direction. But we have to understand that this conservation equation will already incorporate kind of the different vectors of the velocity. So we don't have to make that negative, or else it will give us a totally different value. But yeah, the most important thing is to also understand how this conservation equation works. The conceptual understanding is that momentum is going to be conserved, but breaking it down into an equation such as this is super important in understanding how to solve the problem. If it was a collision, for example, it would kind of be the other way around. Say it was like an elastic collision where the masses stick together, like two masses stick together at the end. We would kind of like flip this equation, but kind of solve it in the same way. So yeah, that's just the most important aspects of this problem, and thanks for listening.